command is no IP. Okay, no IP information. So the command is no IP information option. Okay, so that is what we disable it. If you just type in IP information, snooping information, you are enabling it. So to disable it, you type no IP information option. Okay, so that disable option 82. Hi, great network enthusiasts. It's another beautiful evening here. I hope you're having a good time out there. So today we're going to look at another important topic called DHCP Snooping. A security feature in Cisco switches that is used to prevent DHCP-based attacks such as DHCP starvation attack. Alright, so I've highlighted my step here. So we'll look at them together. First of all, I'm going to create a VLAN 10 and assign those interfaces facing the end host to the VLAN 10, make them access port and assign the VLAN 10 to that. And then I will also make this G01, which is the uplink, an access port also, because we are using only one VLAN here. Then I will make it a trusted port. Then I'll make the router a DHCP server. So I'll create a DHCP pool for this VLAN 10 there, so that it will serve as a DHCP server to those clients. Okay, so without wasting time, let's go straight to doing to the CLI of the switch. Then I will start immediately. This creating of VLAN, creating of DHCP pool is not part of the DHCP Snooping configuration, but I just want to carry it along with you so that you will refresh your memory in case you are forgetting the step to create a DHCP pool and a VLAN. Okay, so because it's not going to take time, I'm going to do everything with you here. So enable conft. To create a VLAN, there are two ways. You can just enter the VLAN like this, VLAN 10. So if I hit enter, I've created a VLAN 10 like this. But the other method is to just assign the VLAN 10 directly to an interface without creating it. So in that case, the VLAN will be automatically created. So I'm not going to waste time here. I will just name this VLAN 10 with name. I'll call it, let's say, sys. Okay, I just did that now. Let me exit out of this configuration mode with exit. Now I will enter interface configuration mode. There are three interfaces here, one to PC1, laptop 0, PC 0. So let me see the interfaces, F01 to F03. So I will use interface range. So interface range. Sorry, let me use question mark. Okay, F0/1 to 3. Okay, switch port mode access. Switch port access VLAN 10. Do right. Okay, so I have created the VLANs and assign it to the needed interfaces. So I will also do the same on this G01. If I make this G01 a trunk port, the DHCP message will not work properly. So I experimented that earlier. So I have to make it a single VLAN. Okay, so which is to make it a VLAN 10 as the other interfaces also. So I will do the same configuration on G01. So we enter the configuration mode again, interface G0/1, switch port mode access, switch port access VLAN 10. Do right to save. Okay, that is all here. And I will go to the router here, enable the interface. First of all, I'll type no, conft interface G0/0/0. That is the interface facing the switch. Alright. Enter. No short. Then I'll give it an IP address of IP address 10.10.10.1, then 255.255.255.0. Okay. What else? Alright, so what I'm going to do next is to create a DHCP pool here, making the router a DHCP server. So exit out of interface configuration mode, and let me create the pool with IP DHCP pool. Followed by the pool name, I want to make it a VLAN VLAN 10 VLAN 10 LAN, VLAN 10 LAN. I've created the DHCP pool for VLAN 10 LAN, so I will specify the default router here with default router. I think, is that correct? Yeah. So the default router will be the same DHCP server address, so 10.10.10.1. Okay. How about DNS server? DNS-server. I'll use it .8.8.8 here as Google server. Then what else? Let me use question mark. Network. Okay, the network we want to use, we want it to be distributing. Okay. Network. Then 10.10.10.0. Then 255.255.255.0. That's correct. So this is the network range that will be given to the end host. I will exclude the IP address for the DHCP server itself, which is .1, but if you want to exclude an address, you do it out of the DHCP configuration mode. So I have to exit out of here. Exit. I think let me do that again. Okay, I'm in global configuration mode now, so I can use that command IP DHCP excluded /address. Question mark. Okay, so the address I want to exclude is 10.10.10.1, which is for the router itself, so that it will not give it to a network host to cause IP conflict. Okay, so do right. I think that's all here. I'm going to go to the end host and then instruct them to use DHCP as the source of IP address acquisition. So okay, as you can see, it has given this PC 10.10.2. It doesn't give it .1 because we excluded .1. So I'll do the same thing here. Okay, so the first Ethernet.3. Okay. Alright, .4. So the next step is to go to the main topic, which is IP DHCP snooping. Alright, so we'll do that on the switch, so that if anyone try to flood the switch with IP DHCP requests, it will drop the message. I believe you know how IP DHCP snooping operates. Okay, so it will create a binding table for the various assigned IP and then uses the DHCP binding table to compare both the IP address of the and the MAC address of the end host. Okay, so that if anyone's tried to spoof a MAC address, it was make a lookup to the DHCP binding table to make sure the IP addresses and the MAC address are corresponding. So if you fake MAC address that is not in the binding table, it will be dropped. So there's another comparison of comparing the hardware address in the DHCP request message itself and compared to the MAC address, to the source MAC address of the sender. Okay, so what we're going to do is to just exit out of this place. Okay, I'm in configuration mode already, so I will first of all enable DHCP snooping with the command IP DHCP snooping. Let me use question mark to see what's next. Okay, I can close it here, CR. So that's just enabling DHCP snooping globally. Alright, so the next step is to apply it to your VLAN you want it to be active on. So we are going to use it on VLAN 10. We are going to use it on VLAN 10. So I will go back. The command starts like the one we just created. So you just add VLAN to the existing command. So I hit up arrow to bring back the previous command. Then I type VLAN followed by the VLAN ID, which is VLAN 10. Okay, so I've created the IP DHCP snooping and I have applied it to the VLAN 10. Alright, so what next is to make uplink a trust port. All ports are trusted by default, so I will make this G01 a trust port. Okay, so I will do that. I have to do that from interface configuration mode anyway, so I will go to interface. Let me see the interface, which interface is that G01, interface G0/1, IP DHCP snooping trust. Okay, so I'll make it a trusted port. All right. So the last command is to disable option 82. It's an option in DHCP, but there's one rule. The reason why you must disable this option 82 is that whenever a switch or even a router receives a DHCP message that is not from a relay agent, that message will definitely be dropped. And in this case, this switch is not acting as a relay agent, so it only broadcasts the DHCP request. So it's not acting as a relay agent. So therefore, we have to disable option 82 on it. So the command is IP DHCP Snooping information option, but I'm not going to do that now. I want to prove a point before I enable it, because it will be blocking DHCP request. So if I do not disable it now, if I try to make a request, a new DHCP request, since I have configured a DHCP Snooping configuration on this switch, it will block that request. So the PC will not get new IP address unless if I disable this option 82. All right. So let's go to testing again. Go to desktop, command prompt. So I want to make this PC to release its IP and then renew it and request for another IP again. So the command is ipconfig /release. Okay, so it just released the IP now. I want to renew it, so the command is config /renew. Okay, so if DHCP Snooping is working, it will block the DHCP request, and it has failed, as you can see. Alright, so I'll go back to the switch and enable disable the option 82, and then come back to this PC again and try to renew the IP address. So it is not done from the interface configuration mode, so therefore we exit out of interface and go back to the global configuration mode, then disable it. So the command is no IP. Okay, no IP information. So the command is no IP information option. Okay, so that is what we disable it. If you just type in IP information, Snooping information, you are enabling it. So to disable it, you type no IP information option. Okay, so that disable option 82. So if I try to renew again, it will come up this time. The IP address will be renewed. Oh yeah, as you can see, it has given it an IP address of 10.10.10.4. It was the previously used IP was still given to it because it's still available. Show IP DHCP pool. Okay, I can just show Snooping, not pool. Snooping. Okay, I can just show it like this to show the entire Snooping, or I can just show the binding table to see what MAC addresses have been learned and then the IP addresses that have been assigned to them. So here it is. Here is few information about the DHCP Snooping we configured. So you see, I told you earlier that all interfaces are untrusted by default, so you have to manually specify the trusted interfaces. So G01 is the one that is uplink, so it's the one that is going to another network device, so we make it trusted port with the command we used earlier. So as you can see, trusted port is G01, so F01 is untrusted. Yeah. So rate limit is unlimited. It's another option, very important, that can limit how many message DHCP requests you can receive on an interface per second, but Packet Tracer doesn't support that. But that fixture is very, very important, so that if anyone tries to flood DHCP request, and if the message is detected to be abnormal or is rushing the switch interface, then the interface can be disabled to prevent the attack. But it's not available on the on this Packet Tracer. Alright, so let me see the table. IP show IP DHCP Snooping binding, right? Binding. Okay, so there's only one binding so far, because since we configure DHCP Snooping, we only make one new request, which is the one we use for this PC to renew the IP address. So if I renew the IP addresses of this other PC, you see that the binding table will increase to 3. So here is this PC 1 MAC address, and here is its IP address. Okay, so if this PC, for example, if anyone tried to release the IP address on behalf of this PC, the switch will make sure it confirms to ensure that it is actually this MAC address that is sending this IP release request, so that another device or another person cannot instruct the router to release the IP address of this PC on behalf of the PC. Meanwhile, it's not the legitimate PC owner. So for it to be sure that it is not another person that is acting on behalf of this PC, it will make sure it check this binding table to compare the IP address and then the owner of this IP address, which is this MAC address. Okay, so I will go to the other PC to do the same thing, to renew their IP address /renew. Okay, so this one just renew its IP address. IP config /renew. So if I check the binding table now, you will see that it has increased. Yep. Okay. So their total numbers of binding is true because there are 3 PCs in this device. The other way, there are 2 ways to test this configuration. The first way is to decrease the rate limit on the interface, but rate limit is not supported on packet tracer, so I can't do that configuration. I can't do that testing. So the other way is to make one of these ports going to this end host a trusted port. Then, if a DHCP request is received on trusted ports, such as a DHCP message, such as discover message, so renew message, release message, if it is received on a trusted port, it will be discarded. The message will be discarded. So the interface may enter error disable mode. But in this case, I tried to experiment that earlier. It was not working. I believe it's still because of packet tracer. So for that, let me just prove that to you. I will just do that. But in reality, in a real network device, it should not work. Okay, if I try to renew on an IP address that is on a trusted interface, it shouldn't be working. But I tried that earlier, it was working. So that is a problem of packet trace anyway. So I'll go back to configuration mode, make this interface, which is F0. Let me see. This is 01. Okay. I'll make this F01 a trusted interface, and then const interface F0/1 DIP DHCP Snooping trust. Yep. So as I make it a trusted interface now, and it's not going to another networking device, and it's not an uplink. If I send a DHCP message, such as DHCP discover message, DHCP release message, DHCP renew message on this interface, it's supposed to not be allowed on this interface. It's supposed to be violating the IP DHCP rules, but in packet tracer it was working. So I believe packet tracer is the one having issue here. So let me try to renew the IP address again. Renew. So it's still working, but in reality it shouldn't be working. So that's packet tracer issue. So aside that, there's no any other way I can test it. So but earlier we see that if option 82 is not disabled, the end devices cannot renew their IP address. They cannot get IP address via DHCP. So we disable option 82. That shows that our DHCP configuration was working. So we disable option 82 before they were able to renew their IP addresses via DHCP. Alright, so that is all for today. So if you like this video, don't forget to subscribe to my channel, like, comment, and share with friends. Have a beautiful day.